take volume? I should have asked. Okay, well, we'll keep going. I hope I didn't just record over what I did. That would be silly. Questions here? Yes?
Well, it's not really a question on this, but like, I don't really fully understand the first part that we learned.
Like how to write the rate equation?
Yeah, like I get what you're doing now, like I understand the concept of it, but like, I'm not sure I'd be able to do it if I don't even get the first.
Okay, so let's look at the next example and we'll write the rate equation first, and then we'll solve it and we'll see if it clicks. Okay. All right, so in the next one we have hydrogen gas reacting with iodine chloride, and we're going to make iodine and 2 moles of hydrogen chloride. It says the rate at which HCl forms is 0.0090 molar per second. So that's what's given. And we want to know the rate of change of iodine. Okay, so the first thing we do, I'm going to rewrite the equation for you so it's right in front of me and everything is together on the page. You don't have to rewrite this. This is in your notes. Okay, so there's the balanced equation. It says the rate at which HCl forms. So the change in concentration of hydrogen chloride gas is 0.0090 molar per second, lowercase s for second, and we want to know the rate of change for iodine. So we have our given and we have our unknown. Now what I do is I write a rate equation with these two substances. So Sheehan, if I had hydrogen chloride, is that a reactant or a product?
A product.
So would I have a positive or a negative one?
A positive.
Right. So you have positive 1. And what's the coefficient of hydrogen chloride?
2.
So I put a 2 here. Then I have the change in concentration of that substance over the change in time. So this quantity will replace this fraction. And I'm going to set it to the iodine. Iodine is a product, positive 1, over its coefficient, change in concentration of iodine over the change in time. Okay? So you write the rate expression or rate equation based on the information they give you. That was like the do now. That's like what we did after the test yesterday. Here comes the new piece where you're going to solve it. This is going to plug in here. You have 1/2 of 0.0090 molar per second, and that's equal to 1 times what you're looking for. You can call it x if you prefer. And so what you've got then is 1/2 of 0.0090 is 0.0045 molar per second. That is the rate at which iodine appears. And again, products appear, reactants disappear. Does that make sense?
What if in front of the iodine it wasn't 1/1?
Right. Then, like, let's say it was 1/3, then I would have multiplied both sides by 3, and I would have had 3/2 of that. And that's exactly what you're going to see in the next problem. That's an excellent question. And you guys are really smart, so I wouldn't give you one of these really easy questions. Go ahead, Sheehan, and then Amanda.
For the first part, like, what to choose. It just says like one reactant and one product, or like one element and one compound. So like, is there anything that you can't choose?
If it says one reactant and one product, you can just pick one of each. If it says an element that's disappearing, you've got to pick the element that's on the reactant side. If it says a compound that's appearing, you have to pick the compound on the product side. Here I picked these two because I was given data about one and I wanted to know the other.
Okay.
Okay.
So for the fraction in front, if you're using a product, it's always positive, and if you're using a reactant, it's negative?
Yes, for the negative one versus positive one reactant product, exactly. Okay. The next question goes with the same balanced equation. And it says if the rate at which iodine forms, so they're telling you, this is the next problem, it just has like a bullet mark there. The rate at which iodine forms, and again, rate is the change in concentration over the change in time, is 0.050 molar per second, and they want to know the rate of disappearance of iodine chloride. So again, what you're given, what you're looking for. So you're going to write a rate equation with these two from the balanced equation. So what would our rate equation be? Plus 1 rate is equal to plus 1 over 1.
Parentheses delta with iodine over change of time equals -1 over 2. The change of iodine chloride.
Why is that a -1?
Because it's a reactant.
Exactly, good. Iodine chloride's on the reactant side, so it's a -1. Where'd you get the 2 from here, Chloe?
The coefficient of iodine chloride.
Perfect. So there's your rate equation or expression. Now what would you do?
And then you fill in 0.050 molar per sec in for the equation. And you have to multiply each side by -2 because you have to multiply by the reciprocal.
Exactly. So I'm going to call this, we'll explain it. I'm going to call this X because it's easier. And what Chloe was saying is that we want to solve for X, which is the change in iodine chloride over the change in time. In order to get X, 1X, we have to multiply both sides by the reciprocal of that. So we're going to multiply both sides by -2. And so what we've got then is that the change in iodine chloride over the change in time is just 2 times that, and so you've got -0.10 molar per second, lowercase s for second. So that's what you're looking at here. So whatever's multiplied to what you want to solve by, you have to multiply by the reciprocal, so this becomes 1. -0.5 times -2 is 1.
So you multiply by whichever one you're solving for?
Yes, because that's how you'll get 1. So, for example, Amanda, if this was, let's say,
Like if you were solving for the iodine, then it would have just been 1 over 1 and 1 over 1.
right. So if this was -1/4, what would you multiply both sides by?
No, -4.
-4, the reciprocal, exactly. You want to get a positive out of it. All right, let's do one more, and then I'll tell you what this corresponds with in your classwork. Oh no, we have lots of fun stuff to do. This is the easy stuff. What? Lots of fun stuff to do today.
Is there ever going to
Split the fraction?
Yeah.
No.
Okay.
Okay. The next problem says that if the rate at which magnesium disappears is negative 0.300 molar per second, calculate the rate at which the element appears. So we'll work this one. I'm going to rewrite the equation here just so it's all together. You don't need to, it's in your notes. And we mastered balancing a long time ago, so this is not an issue. It says the rate at which magnesium disappears, recognize again, a rate is the change in concentration over the change in time, is negative 0.300 molar per second. We want to know the rate at which the element appears, so what are we looking for? The nickel, because that's an element on the product side. Good. Okay, so we're going to write a rate equation with these two. So what should we write?
Rate equals negative 1/3 parentheses the change in magnesium over the change in time.
All right, we'll let Hannah finish up the other half. Go ahead.
The positive one over 2, and the rate of nickel over the rate of change in time.
So the rate is the change in concentration over the change in time. Good job. Now what do we do?
We plug in the magnesium.
Okay, so we have negative 1/3 times negative 0.300 molar per second is equal to 1/2, and like I said, I like to just do x because it's easy. I know what I'm solving for.
And then multiply them.
By what?
Negative 1/3 times negative 0.300, and then by the reciprocal.
Right, and I would just do it all at once. I'd multiply both sides by 2. And then basically you have 2/3 of that.
Would it be negative 2/3?
You have a negative times a negative.
Oh.
Yeah, so negative 2/3 times negative. I was thinking the negative, negative, positive. But however you solve your expressions, as long as you get them correct, is perfectly fine. So yes, it's positive. And that's equal to the change in concentration of nickel over the change in time, or the rate at which nickel appears. And again, you'd expect that to be positive because it's a product, and this piece here is negative because it's a reactant. Rates of disappearance are negative, rates of appearance are positive. And on your classwork, this is similar to 1 and 2. I'll get it to you. Okay? There's another way to calculate rates, and this you can do from data alone. This is almost similar to getting the slope of a line. This will be very, very simple for you.
I don't like doing slope.
This is easy. You'll be good, I promise. Such a hard day. I know. The rate of reactant consumption. We know that reactants get consumed or used up. Products get generated. can be calculated from data. So you might get a data table in which you're looking at concentration of a substance over time. And from data, you can calculate the rates. For example, it says calculate the rate of change for each interval from the data below. Is the average rate constant over the two intervals, yes or no? If no, does it increase or decrease? And we'll do all different variations of this, so you will be successful with it. And then you'll need to explain, and the explanation really is very simplistic. So what we're seeing here is hydrogen, actually that's aqueous, so that's a gas. Aqueous is an acid. Hydrosulfuric acid and chlorine gas react to form sulfur and hydrochloric acid, and sulfur is a very smelly compound. I usually find a strong sulfur smell when we go up to Orlando. It's not so much the hotels, but if you stay in like timeshares and things like that, sometimes when you shower, have you ever noticed like a really putrid smell? No? It smells like rotten eggs. Yeah, in AP we do a lab with Kinetics, and we generate sulfur, and it just smells so nasty. But you have to have gas to do it. We used to also in honors react copper and sulfur together to get copper 2 sulfide, and that too. It's a fun little lab, but it just smells awful. So we should. I got to get the gas working though. It's a fun little lab.
Oh, like the little air thing?
Yeah, the gas. They don't. It's just a lot of them don't work that well. Well, the one up here works well. I don't think a lot of those work well because kids stick their pencils in there, and I think the pencil points get broken in there. Yeah, silly. Okay, so what you're looking at here, what's happening to the concentration of chlorine over time?
As it decreases, the time increases?
So you're seeing as you go through, you're increasing time, so the experiment's progressing, the concentration decreases. Why would the concentration of chlorine gas decrease?
It's being used up.
It's being used up because it's a reactant. So reactants get consumed. So when you look at the data, you want to see whether the concentration is increasing or decreasing, because that tells you whether you have a reactant or a product. Now you know you have a reactant from the balanced equation, but had an equation not been provided, you would know it anyway because the concentration is going down. If you had a product, then the concentration would be going up. So what we want to do very simply is to calculate the rate at which chlorine is consumed. And we're going to do this from the data alone. So you also want to be looking at your data here. Okay, so we know that rate is equal to -1 for reactant over the coefficient 1, change in concentration of chlorine over the change in time. For interval 1, what we can see here is we have -1 over 1. At 25 seconds, I have 3 molar chlorine gas minus 4 molar that I had at time 0 when the experiment started. This was 25 seconds minus 0 seconds. And I probably should put rate right here. So that's going to be -1 times the -1 I probably think I would just write a negative there. I don't think I would write that again. So let me fix that. All right. So we'll just make this a negative. It'll be easier. -1.00 molar over 25 seconds, and that's positive 0.040 molar per second. So that's the rate at which chlorine gas is consumed for the first interval. That's the first interval. We've got to do the second interval. For interval 2, we've got rate is equal to -1/1. Now we've got 2 molar, the concentration at 50 seconds, minus 3 molar, the concentration at 25 seconds, over 50 seconds minus 25. So that's going to be the same thing. This got a little squishy. Are the rates for the two intervals the same?
Yeah.
Yes.
Do you have to put the plus sign in front of it?
No.
or-
I just wanted to make sure you saw the negative and negative. So what we're going to indicate here is that the average rates are constant because they are the same over both intervals.
What if they weren't constant?
Right, and that's a great question right there. That's exactly where I was going. So what would you like the rate to be over the first interval? Pick anything.
Any number?
Well, something close to what we picked, so it makes sense.
.045.
Okay, so 0.045 molar per second, and now pick a rate for interval 2. It just can't be the same.
0.050.
Those are not the same. Is the rate increasing or decreasing? So what you're seeing here is that the rate is increasing. That's my abbreviation right there, arrow up, ing. The rate is increasing because the rate for the second interval is greater than the first. If the rate were decreasing, what would be a reasonable rate for interval 2?
0.040.
0.040 molar per sec would work too. All right, and watch your units and watch your sig figs. Rates are typically concentration per time, molar per second or molar per minute, etc. Okay?
Dr. Tish, you mind going back to the other page so I could?
Sure. Did everybody finish here? And I'm also going to scan all these sheets. So especially today, like with the section we just do, the ones we just did, I think you'll be extremely successful with everything. These, I think, are the easier pieces of the unit. What we're going to get into does tend to be a little more complicated, and some of the kids just really like to watch rather than write. And I'm going to scan all of these today. That's why I was just writing on one side of the page. I'll scan them in color, and I'll get them to Edline in the supplemental note section. And the video or videos, because I stopped it, I thought I could pause it, but I'm not really sure what I did. You guys will help me figure that out. I'll post those too, but I'm not sure if it's going to be one video or two, and I'm not sure. I mean, I shouldn't have been able to like record right over what I did, right? I may have. I don't know what I did, so I don't know. I'm not as techy as you guys. I'm good at stuff, but I'm not great at that stuff. So I'll learn. That's why we're here.
Are we done?
No, we're not done. That's silly.
Are we almost done?
Well, we could take a little break, but here's my question: how do I pause? Like,
You let them watch us eat cookies.
Yeah. You have to make another video.
I have to make another video. So I just hit